Dear students, today I am going to explain you some questions of progression. The first question is, if A, B, C be in arithmetic progression and X, Y, Z be in geometric progression, then prove that x to the power b minus c into y to the power c minus a into z to the power a minus b equals to 1. So since A, B, C are in AP, this implies T2 minus T1 equals to T3 minus T2. That is, B minus C equals to C minus B. This implies now we are changing the positions. So minus A plus B equals to minus B plus A. This implies here minus I am taking common. Then it is A minus B in the bracket and outside the bracket minus. So here also minus I am taking common, then B minus A. This implies this both minus are cancelled, then A minus B equals to B minus C. And now this C is brought this side, then it becomes A plus C and B plus B is 2B. So A plus C equals to 2B. Now again, since X, Y, Z are in geometric progression, so T2 by T1 equals to T3 by T2. So Y by X equals to Z by Y. This implies Y square equals to XZ. Now LHS is given left hand side x to the power b minus c into y to the power c minus a into z to the power a minus b. And here just now we have calculated that a minus b equals to b minus c. So in the case of z power a minus b, I am writing b minus c, and rest x to the power b minus c into y to the power c minus a is constant. And then here you find that x and z both have the power b minus c. So x and z both are written in parenthesis small bracket, and its power becomes minus b minus c into y to the power c minus c. Now again just now I have calculated that y square equals to xz. So here in place of xz I am writing y square to the power b minus c into y to the power c minus c. Now I am removing the bracket, and then this becomes y to the power 2b minus 2c into y to the power c minus c. Now bases are same, so powers will be added. So here it becomes y to the power 2b minus 2c plus c minus c. So 2b is 2b only, and minus 2c plus c becomes minus c and minus a. So y to the power 2b minus c minus a. And just now I have calculated that a plus c equals to 2b. So here c minus a I am keeping in bracket. So when minus is taken common, then in bracket c plus a, and in plus c plus a we are adding 2b. So y to the power 2b minus 2b, that is y to the power 0, that is equals to 1. That is right hand side. So quod erat demonstrandum, that is QED. Now second question is, find the sum of 5 plus 55 plus 555 plus and so on to n terms. So solution is here, let sum equals to s. So s equals to 5 plus 55 plus 555 plus and so on up to n terms. So here 5 we are taking common, then in the bracket it is left 1 plus 11 plus 111 plus and so on to n terms. And after that we are multiplying and dividing both by 9. So it is 5 by 9 into 9, and in the bracket 1 plus 11 plus 111 plus and so on up to n terms. Then here 5 by 9, and this 9 I am multiplying to all this. So it becomes 9 plus 99 plus 999 plus and so on up to n terms. Now 5 by n. This 9 can be written 10 minus 1. 99 can be written 100 minus 1. 999 can be written 1000 minus 1 plus and so on up to n terms. Now 5 by 9. So 10 minus 1, so 10 to the power 1 we can write, because 10 to the power 1 is 10 only. So 10 to the power 1 minus 1. 100 can be written 10 square minus 1. 1000 can be written here 10 to the power 3 minus 1 and so on up to n terms. Now again 5 by 9 into, here all these plus are written together and minus separate. So 10 to the power 1 plus 10 is square plus 10 to the power 3 plus and so on up to n terms. and minus 1, minus 1, minus 1 up to n terms. So 5 by 9, 10 to the power 1 plus 10 square plus 10 to the power 3 into up to n terms, and minus n up to n terms we are adding, so that is minus n. Now here you find that first term a equals to 10, then common ratio is second term by first term, that is 10 square by 10 to the power 1 equals to 10. So here Sn in Gp is a into r to the power n minus 1 by r minus 1, because r is greater than 1. Common ratio is greater than 1, that is 10 here. So we are using this formula, and according to this formula we are writing here 5 and 9 into 10 into 10 to the power n minus 1 by 10 minus 1 minus n. And again that is equals to 5 by 9, 10 into 10 to the power n minus 1 by 9 minus n minus n. And now we are removing the bracket. So this term, there are two terms, both these terms are multiplied by 5 by 9. So 5 by 9 into first term, that is 10 into 10 to the power n minus 1 by 9 minus 5 by 9 into n. And this becomes 10 5 is 50, 9 9 is 81. So 50 by 81 into 10 to the power n minus 1 minus 5 by 9 n. This is the answer that we had to find out. Now, third question is, how many terms of the geometric series 1 plus 4 plus 16 plus 64 and so on will make the sum 5461? The solution is, let the required number of terms be n. So here you find the first term a equals to 1. Common ratio equals to second term by first term, that is 4 by 1 equals to 16 by 4 equals to 64 by 16 equals to 4, and this is greater than 1. And your sum of terms is 5461. So according to the formula, as common ratio is greater than 1, sum of n terms equals to, in geometric progression, a into r to the power n minus 1 by r minus 1. Okay, so this is given 5461 equals to 1, a value is 1 and r value is 4, so 4 to the power n minus 1 by 4 minus 1. This implies 5461 equals to 4 to the power n minus 1 by 3. And now by crisscross multiplication, we are getting 4 to the power n minus 1 equals to 3 into 5461. This implies 4 to the power n minus 1 equals to 16,383. And then this 1 will come right side, and then this becomes 4 to the power n equals to 16,384. And now we are factorizing 16,384. It is divisible by 4. How did you understand? Because 84, last two terms of the number, is divisible by 4, and that's why the whole number is divisible by 4. And then we are factorizing and we get 4 to the power 7 is equal to 16,384. So here in place of 16,384, we are writing 4 to the power 7, and 4 to the power n equals to 4 to the power 7. Bases are same. That's why power will be same, and therefore number of terms of the GP is 7. That is our answer. Thank you. If you like, please share and subscribe.